Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. In the previous chapter, we have discussed about type conversion. We also have discussed about how to read inputs in a console application. In this chapter, we are going to discuss about decision making and conditional statements. For writing conditions, we also need to know some comparison operators. We are also going to have a look at them. The chapter will begin with a quick introduction to if statements. In the second section, we are going to discuss about switch statement and switch expression. In the end, we will have a look at ternary operator and null coalescing operator. So let's get started. We commonly use many conditional statements in our day-to-day life. For example, if it is raining, then I will have to take my raincoat with me. If I get good bonus, then I will plan a nice vacation in the summer. Or if I become the president of this country one day, I will lower the taxes. Similarly, a computer program may also need to take some decisions. We all know that a computer program is a set of instructions. Those instructions are executed step by step by the computer. Every instruction is to perform certain tasks. And in some cases, program may need to take certain decisions based on the outcome of previous tasks. Let's take an example. Let's say we want to write a program which takes a number as input, and then the program needs to display the text indicating whether the input number was even or odd. A number is even if it can be divided into two equal groups. It means if we divide that number by 2, the remainder should be 0. So based on this mathematical condition, our program needs to decide which text should be printed. For taking such decisions, we can use if statements. The if statement begins with if keyword followed by a condition inside the bracket. The condition inside the bracket must always evaluate to a Boolean value, indicating whether the condition is satisfied or not. So let's have a look at the sample code. The sample code shown here takes a number as input. Then the next instruction is to find out remainder after dividing the number by 2. The percentage sign here is also called as modulus operator. It is used to find the remainder after the division. Note that / is division operator. It tells us the result of division, while the modulus operator is for knowing the remainder after performing the division. So now that we know the remainder, we need to decide if the remainder is 0 or not. So for that, we can write an if statement. And in the brackets, we can check if remainder equals to 0. This condition here checks if the remainder is 0 or not. And if this condition is satisfied, then the control of execution goes inside the if block and prints the text. You must already have noticed that we have used double equal to sign. In C#, single equal to sign is for assigning the values, while double equal to sign is for comparing the values for equality. You must have also noticed the curly brackets after the if statement. Those curly brackets should contain the code block which needs to be executed when the condition is true. In this example, if the condition is true, we just want to display that the number is even. So we just need a single statement console.writeLine to print the text. Note that if there is a single statement to execute, then the curly brackets are not required. They can be dropped. But I generally prefer having the code block surrounded by the curly brackets to explicitly mark the boundaries. Currently, our program just identifies if the number is even. If the number is odd, it doesn't print anything. So what can we do to add another alternative path of execution in our program? For that purpose, we can use else block. The else block is executed when the condition specified in the if is not satisfied. That is, the condition specified inside the if should evaluate to false. In our program, there can be only two possible values for remainder. The remainder can be either 0 or it can be 1. And if the remainder is 1, that means the number is odd. We already have handled one possible case in the if block. When the condition specified in the if statement is false, then the control skips the execution of the if block and it goes to else block only if else block is present. And that's why for printing that the text is odd, we just need to add an else block which starts with an else keyword followed by curly brackets. And inside these curly brackets, we can add console.writeLine to print that the given number is odd. Here as well, curly brackets are optional. If the else block contains a single line of code, then curly brackets are not required. But I would again recommend to keep using curly brackets to avoid any confusions while reading the code. The code that is written between these curly brackets is called as if block, and the code that is written between the curly brackets followed by an else keyword is called as else block. Note that else block is completely optional. If we do not want to perform any action when the condition specified in the if statement is false, then we can simply have an if block without any else block. Program was supposed to handle only two possible outcomes of one condition, and that's why adding a single if else was sufficient. But what if decision making is more complex? What if the decision has more than one condition and more than two possibilities? Now let's look at another example. Here we need to decide the grade of the students based on their score. Grade can be either A or B or C based on the bucket in which score falls. The flowchart here shows the step-by-step instructions, and we are going to use this information to write our C# program. This flowchart is showing series of conditions. The first condition is to check if the score is greater than or equal to 90. Here we have used a greater than sign followed by an equal to sign to check the greater than or equal to condition. If this condition is true, then it prints that the grade is A. But if this condition is false, then the next condition comes into play. The next condition is for checking if the grade is B. If the next condition is true, then the program prints the text corresponding to B grade and program exits. If the condition is false, then the third and last condition is executed. If the third condition is true, then the text for grade C is printed. If the third condition is false, then the program prints that the student is failed. Now here the failed text would be printed if the score does not fall into any of the three buckets specified by three previous conditions. That is, all those three conditions should be false. For programming such decisions, we can use if and else syntax. Let's now convert this flowchart into a C# program. The C# program will start with an instruction for accepting a number as input, and then there is an if statement to check if the score falls into the first bucket. If the condition is satisfied, then the program prints the text corresponding to grade A and program exits. In this case, it doesn't check any further conditions. If the condition for grade A is not satisfied, then the next condition is evaluated. Here, the next condition is specified in else if statement. Else if also behaves similar to if statement. If the condition specified in the else if is satisfied, then the text is printed and program exits. When the condition for grade B specified in else if block is not satisfied, then the next else if condition is evaluated. The execution goes like this until the else block is found. When the condition specified in an else if block is not satisfied, then the next else if block is evaluated. And this goes on. If none of the else if blocks evaluate to be true, then an else block is executed if it is present. So, else block is executed only if all previous conditions specified using if statement or else if statement are false. Here also, else block is optional. We can skip it if we don't need it. So, in short, when we want to perform any decision making in our code, we can use if statements. The if statement can optionally be followed by one or more else if statements, and an else if statement can optionally be followed by an else block. The else if blocks are evaluated in the order in which they are specified. If one else if condition is false, then the next else if condition is evaluated, and this goes on. Okay, now we know enough about if statements, but for writing conditions, we will need to know about comparison operators. So on this slide, let's have a look at commonly used comparison operators. Some commonly used comparison operators are greater than or equal to, less than or equal to, and then equality comparison and inequality comparison. We use same symbols for comparison that we use in regular mathematics. Just for checking the equality, we use double equal to sign. As stated earlier, single equal to sign is for assigning the values, while double equal to sign is for comparing the values for equality. An exclamation mark followed by an equal to sign is used for checking that the two numbers are not equal. The comparisons are straightforward for value types. The comparison operators will just compare the values and they will return a Boolean value indicating whether the comparison was satisfied or not. For reference type, comparison is bit different. So let's take an example. Let's say there are two objects P and Q. Both are of same reference type and both of them contain the same value as shown in the picture. And now if we use equality operator to check if P and Q are equal, the comparison would return false. Why? Because by default the double equal to sign compares the references for reference types, and as P and Q are pointing to the different memory locations, the equality check would return false. Optionally, we can change the behavior of this double equal to sign for a reference type by using operator overloading. We are going to learn about operator overloading later in this course. Now it's time to write some code. Let's say we take two numbers as input and then we need to print which number is greater. For that, we can start with console.write for asking user to input a number. And then let's say we add console.readline to take the input in a variable called as temp. After that, we can use convert class to convert the input value from string to decimal. We can also avoid having a temp variable and we can write a code like this where console.readline is being passed as a parameter inside the brackets of convert.toDecimal. C# always evaluates innermost brackets first while evaluating any expression. So in this case, console.readLine will be evaluated, which returns the user input as a string. And this returned string value will be passed as a parameter to convert the 2 decimal for type conversion. After that, let's say we want to print an empty line. For printing an empty line, we can just call console.writeLine without passing any parameters to it. Now, I will copy the same syntax for reading the second number. So we have a code now which accepts 2 numbers as input. Now, the code needs to decide which number is greater. There are 3 possible cases in this problem statement. First case, where first number is greater than the second number. Second case, where second number is greater than the first. And the third case, where both numbers are equal. So let's start with the first case. We will add an if statement and we will check if first number is greater than the second. Here we have used greater than operator, and now if this condition is true, we want to add a console.writeLine to print that first number is greater. There are 2 remaining possibilities, and hence we cannot use else here. Else block is generally used to make if statements exhaustive. This means else covers all the remaining cases which are not satisfied by the if condition. As there are 2 conditions in our case, we will add else if, and this else if will be followed by the condition to check if second number is greater than the first, and if this condition is true, we are going to print that second number is greater than the first one. Now the last possibility is remaining. In the last possibility, both numbers would be equal. But as there were only 3 possibilities and we already have explicitly checked 2 possibilities by adding the conditions, we can just add an else block here. In this else block, we can just add a console.writeLine to print the text that both the numbers are equal. Let's try to run the program and enter 10 as first number and 20 as second number. The program correctly prints that second number is greater. If we run the program again and enter 200 as first number and 100 as second number, then the program correctly prints that first number is greater. And third time when we run the program, we will provide equal numbers and the program correctly identifies that both numbers are equal. It seems our program is running as expected. You must already have noticed that program does not check subsequent conditions after a matching condition is found. Now let's write another program. Let's say we want to write a program to accept a number as input. This number is supposed to be some kind of percentage. And let's say we want to implement a rule that this number should always be between 0 and 100, where 0 and 100 are allowed values. This time we are going to use console.write instead of console.writeLine for asking the user input. And then the same syntax, console.readLine for reading the input, and then convert.toDecimal to convert the string value into a decimal value. So we have the input ready. Now we want to check if the value is between 0 and 100. So basically there are 2 conditions to check. The number should be greater than or equal to 0 and number should also be less than or equal to 100. Let's start with an if statement where we are going to add a condition to check if percentage is greater than or equal to 0. We are using greater than or equal to sign because 0 is also a valid value. Okay, we have an if statement ready now. We still have not checked for the other condition. So inside this if statement, we can add another nested if statement checking if the percentage is less than or equal to 100. If this nested statement is true, then we will add a console.writeLine to print that input is valid. Now if the input is invalid, then we also want to show the user that the input provided was invalid. How are we going to do that? Let's say for now we add an else block for the nested if statement. Let's run the program to see if program executes as expected. Enter a valid value 99. Program correctly prints that the value is valid. Now run the program again and let's input 101. Program correctly prints that the value is invalid. Next, run the program again and input another invalid value, -1. This time, program does not print anything on the console. But why? This is because we have added else block only for nested if statement. The nested if statement will be false if the number is greater than 100. But there is also a top level if statement which checks if the number is greater than or equal to 0. And for that if statement, we have not added any else block. And that's why when the number is negative, program doesn't print anything. Let's add an else block here for the top level if statement and let's print that the number is invalid if it is negative. Now if we run the program again and we provide any negative value as input, the program will correctly identify that input is invalid. Although we could make the program work by using nested if statements, there is also another way. We can combine both the boundary conditions together in one condition. For that, we can use conditional AND operator. But before that, let's have a look at all the operators which can be used to combine the conditions. As shown on this slide, there are 2 conditional operators which can be used to combine the conditions. Let's start with conditional AND operator. A conditional AND operator returns true if both the conditions that it combines evaluate to be true. The conditional AND operator evaluates the left side condition first. If the left side condition is evaluated to be true, then the right side condition is evaluated. If the left side condition is evaluated to be false, then the right side condition is not evaluated and the whole combined expression returns false. The other operator is conditional OR operator. It is represented by two vertical lines, sometimes also called as double bars. If conditional OR operator is used to combine the conditions, then the combined conditions returns true only if one of the two conditions is true. Conditional OR operator evaluates left side condition first. If it is true, then the right side condition is not evaluated and the whole expression returns true. If the left side condition is false, then the right side is evaluated. Similar to these conditional operators, there are also some other Boolean operators. We already have seen a negation operator represented by an exclamation mark. This is a unary operator. It means that the operator needs a single operand. It logically negates the operand's value. For example, if the operand is true and if the negation operator is applied to it, then the expression will return false. Similarly, there are three more operators. Let's have a look at logical AND operator. It is represented by a single ampersand character, and the logical AND operator is a binary operator, so it needs two operands. It returns true if both the operands evaluate to be true. The next is logical OR operator. It is represented by a single vertical bar. It is a binary operator, so it needs two operands, and it returns true if any one of the operand evaluates to be true. The third operator is logical exclusive OR operator or logical XOR operator. It returns true if both the operands are not equal. So it produces same result as inequality comparison. So after looking at these Boolean operators, we may have one question. The logical AND operator seems to be producing the same outcome as conditional AND operator. And similarly, the logical OR operator also produces the same outcome as conditional OR operator. And the obvious question is, what is difference between conditional operator and logical operator? Let's start with logical AND operator. Although logical AND operator produces the same outcome as conditional AND operator, there is one difference. The logical AND operator evaluates both the operands before returning the result, while conditional AND operator does not evaluate the right side operand if left side operand evaluates to be false. Similarly, logical OR operator also differs from conditional OR operator in the same aspect. The logical OR operator evaluates both operands, while conditional OR operator may evaluate a single operand if the left operand is found to be true. Now that we have seen all the operators which can be used to combine the conditions, let's continue with our previous code example. In this code example, the input is valid if the input falls between 0 and 100. We implemented this validation by using nested if conditions. We can change this implementation and use the conditional AND operator instead. So let's remove this code and add a new if statement and then combine both the condition by using conditional AND operator like this. If this condition is true, then we will add console.writeLine to print that input is valid. And if this condition evaluates to be false, then a single else block would be sufficient to print that the input is invalid. Now, if we run the program again and provide negative value as input, or if we provide any value which is higher than 100, then the program will correctly identify that the input is invalid. In certain cases, we may need to use more than one operators to combine multiple conditions together. If the combined conditions contain multiple conditional operators, then the operator precedence decides the order in which the expression will be evaluated. This slide shows default order of precedence. If the expression contains negation operator, it is evaluated first. This is followed by the logical AND operator, logical XOR operator, and logical OR operator in that particular order. After logical operators are evaluated, conditional AND operator and conditional OR operator are evaluated in that order. This is the default order of processing, and this default order can be changed by using the parenthesis. And if we used parenthesis, then the innermost parentheses are evaluated first. To understand the concept of operator precedence, let's take another code example. In geometry, a triangle can be categorized into one of the three categories. It can be equilateral triangle if all the three sides have same length, or it can be isosceles triangle if any two sides have the same length, or it can be a scalene triangle if all the three sides of the triangle have different lengths. We will write a program to accept three numbers as input. Those three numbers represent the lengths of three sides of a triangle, and then our program will identify the category of the triangle. So let's begin the program with a console.write statement. Here we are going to ask user to provide the length of first side of the triangle. After this, let's add console.readLine to read the input and then convert.toDecimal to convert the string input into decimal. We are using decimal type here because the length can be specified as a number which contains a decimal point. In fact, for that matter, we could use float or double, but let's use decimal for the sake of this demo. Okay, so we have got all the required inputs. Now let's see which decisions we are required to take. Let's start with deciding if the triangle is equilateral or not. Checking for equilateral triangle is simple. we just need a if statement to check that the length of first side is equal to length of second side and the length of second side is equal to length of third side. Here we are using conditional AND operator to combine the conditions. Inside this if block, we can add a console.writeLine to print that the triangle is equilateral. Okay, first case is done. In the second decision, we will check if the triangle is isosceles. So let's add an else if. We are adding else if statement because we want to execute this condition only if the previous condition is false. The else if condition here is bit tricky. We need to check that any two sides of triangle are equal. There are three possibilities. Maybe first side and second side have same length, or maybe second side and third side have same length, or the other possibility is third side and first side have same length. If any of these three conditions is true, then we want to display that the triangle is isosceles. And that's why here we will use conditional OR operator to combine the conditions. Now if this condition is true, then the control will go inside this block, and inside this block we will add a console.writeLine to display that the triangle is isosceles. If the triangle is not equilateral and if it is not isosceles, then it must be scale-in. So we can just add a simple else block, and inside that else block we can add a console.writeLine to display this message. Okay, it seems our program is ready. Let's try to run the program. First provide the inputs 12, 12 and 12. The program correctly shows output that the triangle is equilateral. Now run the program again and let's provide 12.5, 12.5 and 13 as inputs. The program output shows that the triangle is isosceles, which is also correct. Now run the program again and provide three different numbers as input. Let's say 3, 4 and 5. In this case also, program shows correct output that the triangle is scale-in. So let's have a closer look at the program. The first condition is to check whether a triangle is equilateral or not. And hence, in the else if block, we already know that all the three sides are not equal. And that's why specifying this condition is sufficient. But let's say instead of checking for equilateral triangle first, we want to check for isosceles triangle. So I will now reorder the conditions and let's try to run the program. Now, if I provide equal lengths for all the three sides, the program shows output that the triangle is isosceles triangle. Although technically it is also an isosceles triangle, we wanted our program to print more specific category, that is equilateral triangle. What can we do now to make this condition in the if block stricter? Now this particular condition contains three subparts. Currently each subpart is checking whether any two sides of triangle are equal or not, and each subpart checks the length of two sides. But what it is missing is it should also check that the length of third side is different from the length of remaining two sides. So in the first subpart of the condition where we check that the length of first side is equal to length of second side, we will use conditional AND operator to add one more condition that the length of first side is not equal to the length of third side. And we will make similar modifications in remaining two subparts. Now this condition has become very long and it uses two different types of operators, conditional AND operator and conditional OR operator. We have not specified any additional parenthesis here. So the default order of operator precedence will be used to evaluate this expression. Sometimes in the real world applications, the conditions can be very complex, and that's why it may be better to use parentheses to explicitly specify the order of evaluation. In this example, if we want, we can also explicitly add parentheses around the three subparts like this. But even after adding them, the expression would be evaluated in the same order, and hence the behavior of program will not change. The point to note here is, sometimes it is better to add parentheses to make the conditions more readable. If the conditions are more complex to understand in the first look, then we can also extract the condition into a method which returns a Boolean value, and then call that method from the if statement. I hope this example was useful to understand the order of operator precedence. Let's move to another type of conditional statement, a switch statement. A switch statement takes an expression as input. Inside the switch block, there can be multiple case blocks. Every case block starts with a keyword case followed by an expression or a constant value. The expression mentioned in the switch is compared with expression from each case. As soon as the first match is found, matched code block is executed. Every case block ends with a keyword break. This break keyword passes the control of execution outside the switch statement. Instead of break statement, we can also use return statement to return from the method which contains the switch statement, or else we can use a throw statement to throw a new exception. Switch statement may contain a default case at the end. This default case is very similar to else block in if statements. If no matching case statement is found, then the default code block is executed. If the switch does not contain the default code block and none of the cases matched with switch expression, then the control just falls through the switch statement. Until C#6, the switch statement was little different than it is today. At that time, it was allowing only constants in the case statements. Expressions were not allowed. This snapshot shows one example of the switch case statement with constants. Note that this syntax is still valid with the latest versions. Starting with C#7, any expression can be specified in the case statement. For example, the code shown here has two cases with expressions. One case checks if the percentage is less than 0, while the other case has expression to check if the percentage is greater than 100. If any case statements matches with the expression specified in the switch statement, then the corresponding code block would be executed. Till now, we have had introduction to keywords like switch, case, default, and break. There is one more keyword which is used with switch statements. The keyword is when. Every case can also have guards. A guard is an additional condition that can be specified using the when keyword. If we look at the sample code shown here, the case has a guard specified. The case block would be executed only if the value in number variable is equal to 25 and the value in another number variable is equal to 20. Here, the condition specified using another number variable is the case guard for this particular case. We already have seen what is the difference between an expression and a statement. An expression evaluates to some value, while statement is a line of code that just does something. Till now, we were speaking about switch statement. In C#8, a new expression was introduced, switch expression. The syntax of switch expression is very similar to the syntax of switch case statement. The only difference is, being an expression, switch expression must always return a value or throw an exception. Switch expression is also like a switch statement. It starts with switch keyword. Instead of cases, switch expression contains expression arms. The expression arms are separated by comma. Each expression arm may contain a guard. The syntax of guard in switch expression is same as syntax of guards in switch statement. Each arm expression is supposed to evaluate to a value. When switch expression is executing, the expression from the switch is compared with each expression arm. As soon as the code finds the matching arm, the corresponding code block is executed. The corresponding code block is also an expression, so it should evaluate to a value, and that value is returned by the switch expression. Instead of default keyword, the discard pattern is used in switch expression. The underscore used in this sample code is the discard operator. It matches to any value, including null. It works like default case. If the value of switch expression matches to the value of any expression arm, then that particular arm is executed. Otherwise, the discard arm is executed. Okay, that was the quick introduction to switch statement and switch expressions. Now let's try to write some code using switch keyword. Let's first start with switch statement. Let's say we want to write a program that takes a number which is between 1 and 7. Both 1 and 7 are valid values. And based on the input, we want to print the text telling which day of week this input number corresponds to. For example, if 1 is the input, then the program will print Monday. For 2, the program will print Tuesday, and so on. So let's add our code to ask for input number. After that, we can add the switch statement, and after the switch keyword, we can specify the input number variable. Now inside this switch statement, we can add one case for each day. Let's start with case 1. If the switch expression matches with this particular value, we want program to print Monday. So inside case 1 block, we will add a console.writeLine to print Monday. And that's what basically we wanted to do if input number is equal to 1. So after console.writeLine, we will add a break statement so that the control goes out of the switch statement and it doesn't execute the subsequent cases. Similarly, we will add cases for remaining days of week. We can also add a default case to print that the number was not valid. This case would be executed if number was not between 1 and 7. Now if we run the program, we can see that program is correctly executing the code and we can see appropriate outputs. Now let's try to write switch expression instead of switch statement. As we know, switch expression must return a value. In our case, we want that value to be a string. So let's declare a string variable, day of week. After that, add an assignment operator followed by the input number variable, and after input number variable, a switch keyword. Now inside the switch, we can add expression arms. Let's start with arm for constant value 1. In switch expression, instead of colon, we use equal to and greater than sign to begin the corresponding code block for an expression arm. If the input number is 1, we want to return Monday. So here, just add Monday in double quotes. Similarly, add cases for rest of the days of week. At the end, we can use discard operator to return the text corresponding to invalid input. Now, the day of week variable contains the text that we need to print. So after the switch expression, we will add console.writeLine to print the value of that variable. Okay, I hope this code example was helpful to understand the concept of switch statement and switch expression. Let's move on to the next section. In this section, we are going to have a look at two operators. The first operator is ternary operator. A ternary operator sometimes is also called as conditional operator. This slide shows the syntax of ternary operator. It starts with a condition followed by a question mark. Then the question mark is followed by an expression which should be executed if the condition is true. This expression is followed by a colon character. This colon character is then followed by an expression which should be executed if the condition is false. This behavior is also similar to if-else statement. There is only one difference. The else part in if statement is optional, while the colon part in ternary operator is not optional. It always needs to be specified. The first code snippet on this slide shows the if statement for checking if a number is negative or not. In this code snippet, you must have noticed that we are not using console.writeLine to print values, but we are assigning the strings to a string variable. The same code can be rewritten using ternary operator as shown in the second code snippet. The ternary operator checks the same condition and returns the text to be printed. After ternary operator, the second operator that we want to understand is null coalescing operator. This operator is represented by double question marks. This is a binary operator, so it needs two operand. Left operand is followed by double question mark sign, and then it is followed by a right operand. The null coalescing operator checks if the left operand is null. If the left operand is not null, then the left operand's value is returned. Otherwise, right operand's value is returned. Let's move to the code. Let's write a program which identifies if a number is a two-digit number or not. A number is a two-digit number if it is greater than 9 and less than 100. So we can add this condition in our code. If this condition is true, then we can return a text saying that it is a two-digit number. And if this condition is false, then we will return the text that the number is not a two-digit number. The ternary operator is not directly calling console.writeLine to print the text. It is just evaluating to a string value, and then this string value we can print to the console by using console.writeLine. And now if we run the code, we can see that the code is producing the expected output. Next, let's try to understand null coalescing operator. Let's say we declare two string variables. The first string variable is null, while the other string variable is not null. It has some value. Let's say ABC. Let's use null coalescing operator on first string variable. As a right operand, we are going to specify some hard-coded text here. Let's say first variable was null. After this, let's use the same operator on second string variable as well. As a right operand of null coalescing operator, let's specify the same hard-coded text here as well. We can display the results on console by using console.writeLine. Now we can run the program and see that first result is printing the value of right operand as first string is null. However, second result is printing the value of second string variable. This is because the second string variable was not null. I hope these code examples were useful to understand the concept of ternary operator and null coalescing operator. Let's move on to the last section of this chapter. This slide shows some exercises that you can try on your own. The first exercise is to read 3 numbers as input and then print the greatest number. Second exercise is to read 3 numbers as input. Those 3 numbers should represent the length of 3 sides of a triangle, and then the program must identify if the triangle is a right angled triangle. Third exercise is to take 2 decimal numbers as input. The first number should be the height in centimeters, while the second number should represent the weight of a person in kilograms. Use these 2 numbers to calculate BMI. After that, the program must print the category in which BMI falls. Refer Wikipedia page to understand the categories of BMI. This would be helpful for you to decide which conditions are required in your program. Fourth exercise is to take a number as input which represents a year in Gregorian calendar, and then the program must identify if that year was a leap year or not. Okay, this brings us to the closure of this chapter. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.